So let's see now what is the machine. The machine is the mechanism or a combination of mechanisms which, apart from imparting definite motion to the parts, also transmit and modifies the available mechanical energy into some kind of desired work. Okay, so as we have already discussed, machine is a single mechanism or combination of mechanism. What does it do? It, apart from imparting definite motion, that means like rotary motion is converted to the reciprocating motion. Apart from this, what does it do? It can also convert one kind of energy, that is mechanical energy, into some kind of desired one. So what we can say that a mechanism is a fundamental unit, and one has to start with this study. That means whenever we are starting with the theory of machine, we have to start with the fundamental of a machine, that is mechanism. Now what are the different examples of the machine? Let us see lathe machine. In the lathe machine we are having different mechanisms over there. That means some pulleys are there, gearboxes are there, such mechanisms are there, and it converts mechanical energy into rotational motion for machining operation. Second example, car engine. It combines different mechanisms like slider crank mechanism, valve mechanism. That means we can open and close the valve with the valve opening and closing mechanism, and it converts chemical energy into mechanical energy for propulsion purpose. Third is bicycle. Uses different mechanism like chains, sprocket, then gears and brakes, so that we can control the speed. Similarly, crane is there, then elevator is there, drilling machine is there, then printing press is there, washing machine is there, then robots are there. So all these machines are having inbuilt unit mechanism. Okay, fundamental mechanism is there. So that is nothing but your machine. Now your theory of machine subject is broadly divided into two categories: theory of machine, instead of that study of mechanism. Study of mechanism is broadly divided into two categories. One is nothing but kinematics, and second one is the dynamics. Now what is the difference between these two? So in case of kinetic, we are studying the displacement, velocity and acceleration. This we are using, or this we are doing in kinematics. In dynamics we are doing the force analysis. Okay, whatever forces are acting on this. So again there are two kinds in the dynamics also. One is statics and second one is the kinetics. So such categories are there for the study of mechanism. In our current syllabus we are mostly focusing on the kinematics of mechanism. That means we are largely studying the displacement, velocity and acceleration of a particular point on the mechanism or at the particular end of the mechanism. Okay, that means suppose we are having slider and crank mechanism. This we are going to analyze in the second unit also. This is my slider and crank mechanism. In this case, what will be the velocity of piston, what will be the displacement of the piston, and what will be the acceleration of piston, that I have to find out. Okay, similarly, if I am having some angular displacement, angular velocity omega, angular acceleration alpha, if it is these values are provided, then what will be the displacement of the piston, that we have to find out. So that is the part of kinematics, that is displacement, velocity and acceleration analysis. Okay, we are not seeing the part from dynamics right now. We are mainly focusing on displacement, velocity and acceleration. Okay, again study of mechanism can be again divided into two parts. Study of mechanism can again be divided into two parts. One is nothing but synthesis of mechanism, and second one is the analysis of mechanism. Okay, so what is the difference between two? Let's try to understand with the help of some basic example. Okay, synthesis of mechanism and analysis of mechanism. So what is the analysis of mechanism? In analysis of mechanism we are having existing mechanism. What we are having? We are having existing mechanism, and for this existing mechanism we are finding out what will be the velocity, displacement, and acceleration at various point on the mechanism. Okay, at various point on the mechanism. For example, I am considering the example of slider crank. Why I am always considering the example of slider crank? Because it is very easiest mechanism. Okay, there we can easily understand the linear movement of the piston or slider. Okay, so this is your omega. Then omega is nothing but angular velocity of this at particular angle theta. Okay, then velocity, displacement and acceleration of piston I have to find. Okay, that means I am having the length of this first link, so I will call it as A, B and C. If I know this angle theta and AB is like 30 centimeter and BC is like 45 centimeter, if I know the lengths of this link, okay, and if I know the angular velocity like 5 radian per second, then I can find out what is the velocity of point B, what is the velocity of point C. Okay, so whatever existing mechanism, we are having the mechanism with crank length 30 mm, connecting rod length 45 mm. So when we are having the ready-made mechanism, existing mechanism, and for that mechanism we are finding out such thing like what will be the velocity, displacement and acceleration. That is known as an analysis of mechanism. Now synthesis of mechanism is exactly reverse of it. In the synthesis of mechanism, what we are doing, we are designing mechanism or lengths of links of mechanism. Okay, what is the example of it? The same I will consider over here. Okay, so in this case I have to find out length, I have to find out the length L1 and length L2 such that my piston will move with velocity 5 meter per second. How much is the linear velocity of the piston? 5 meter per second. So in this case L1 and L2 lengths are not known. I will give this angle theta, and omega is also known. Suppose omega is 5 radian per second. Okay, then to get the value of velocity 5 meter per second, what should be the value of my length L1 and what is the value of my length, what should be the value of length L2, such that I will get the 5 meter per second as a velocity of slider. So in this case mechanism is not existing. We are designing the mechanism such that we are getting a particular velocity or whatever acceleration, right? So this is the basic difference between synthesis and analysis. In analysis we are focusing on the existing mechanism, and in case of synthesis we are designing our own mechanism such that it will satisfy the condition of example here, like the slider should move horizontally with 5 meter per second. Okay, so this is nothing but the different aspects of the machine and different classification for the study of mechanism. Okay.